Swayam Prabha. Digital India. Educated India.
Okay, so we talk about we have seen the differential attack, which is a non-generic attack on block cipher. So we will continue that, and we talk about some variant of differential attack like impossible differential attack, truncated differential attack, higher order differential attack. So those are some variant of differential attack. So in this talk we will talk about one variant like which is called boomerang attack on block cipher. This is also a non-generic attack. So let us just recall what is the differential attack we discussed. So for the differential attack, it is attack on a block cipher, on a R round block cipher. So if we have a R round block cipher, that means we have the R many round function. Then the last round is FR, and this is the plain text, this is the cipher text. Now if we have some this we call F, and this is the rth round key, and if we have some differential exist, alpha is going to beta in F with significant probability, high probability. Then we have seen we can find the KR, I mean the rth round key, by mounting the differential cryptanalysis, but for that we need to have this. So let us write the step of this attack. So these are the steps of this attack. Step 1. So this is the differential attack on block cipher, R round block cipher. Okay, in the first step what we do, we will try to find out that alpha beta. So find an R minus 1 round differential, alpha is going to beta. That means if the input difference is alpha, then the output difference will be beta in F with high probability. High probability. This is the first step. So we need to have this alpha beta, otherwise it will not, we cannot have the differential attack to work. This is step 1. Step 2. So once we have this alpha beta, then we can think of finding the rth round key or KR. So for that we keep a counter for each possible round rth round key, KR, and we initialize this by counters 0. Initialize, we initialize this counter, initialize the counter to 0. All the counter value are 0. This we have already discussed in the last lecture. Then in step 3, what we are doing, we are picking a plain text. So suppose plain text is n bit. So this is our F, this is our KR, and this is our ciphertext. So we know we have a alpha beta here. If the input difference is alpha, output difference will be beta. So alpha is this differential we have. Okay. So now we choose. Now we need to choose the input difference alpha in a plain text. So, for that we take a uniformly, we pick a plain text x uniformly at random. That means we just, if the plain text is, say if it is n bit, then the plain text space is all possible n bits. So, we choose a x from this randomly, which is a n bit vector or n bit number, okay, 0 1 bit at random, and then we choose, we take x star, which is basically x XOR alpha, is another plain text, so that their difference will be alpha, and we encrypt both these plain texts, encrypt both x and x star. This is a chosen plain text attack. This is a chosen plain text attack. So, we can choose the plain text and can get the ciphertext, because we have to choose the plain text such a way that their difference is alpha. Okay. So, we encrypt both x y and we get the ciphertext, say C1, C and C star. Okay. And then we use this candidate key to, then we use a candidate KR to inverse to compute y, which is basically f r inverse. So, for this we need to have, so this is on C, we need to have KR and y star, which is basically f r inverse C star KR. So, we choose a candidate key, this we have to do for all possible keys, and then we check whether y XOR y star is beta or not. If it is beta, then we increase the counter corresponding to KR by 1. If is beta, then increase the counter value of KR by 1. Okay. And then we will again go to, we repeat step 3, we again choose a x. So, we do for all possible x until we get a significantly more value in the counter for some XR. So, this is the step 4, we repeat we repeat step 3 many times until some KR has significant counter value. That means, suppose almost all counter values are say 10, 12, and suddenly one counter we are observing is more, like, so we have KR. So, we are taking all possible values of KR, say 0, 1, 2, depending on the size of the k bit. If k is say L bit, then it is 2 to the power L minus 1. So, we take a particular KR and all are initialized by 0. Then we do this, once it is matching, then we add a 1 like this. So, this process we repeat until we get a significant values in this counter for a for a particular KR, and that corresponding KR is say for Km we got a 100 and this like this, then obviously this will be the key. Okay. So, this is the version of the differential attack, and for impossible differential attack there is one variant of this differential attack which is called impossible differential attack. Okay. So, this attack is similar. So, instead of high probability we have with very low probability. So, we have a alpha beta differential which is having very low probability. So, that is why it is called impossible, and in this counter what we do, we just repeat this and we just increase the counter like this, and if we see in this counter we repeat the step 3 if some significantly counter value is low, has significant low value, low counter value. So, that means say all are say 50, 90, I say 81, 90, 79, suddenly one value is say 2, then 2 is the, because we have this low probability for this. So, this is the version of impossible differential attack which was introduced by Beham in 1999, and this differential cryptanalysis was introduced on DES to break DES by Beham and Samir in 1993, I think, yeah, 1993. And they broke the DES. So, this is the best known attack after the exhaustive search attack of Electronics Counter Foundation. So, this is the, so I think in 1993, I think, yeah, 1993, Beham and Samir attack on DES by differential cryptanalysis. And for this attack they have the chosen the size of the plain text 2 to the power 47 chosen plain text. So, this is a chosen plain text attack, and size of the plain text they have chosen is 2 to the power 47. So, that is the complexity of this attack. So, this was broke, the DES was broke by this differential crypto, and they have a book on this. And so, there are some other variant of differential attack is also there, like truncated differential attack, higher order differential attack. So, we will not discuss all this. So, higher order. So, instead of first order we will take second order difference. Okay. Higher order differential attack, differential cryptanalysis. So, these are there in the literature, if you are interested you can have a look. So, this was introduced in 1995, I think 1995 by Sen and Lai, and then another version is the truncated one. Truncated differential attack was introduced by Knudsen in 1995, and another version of this differential attack is boomerang attack, which we will discuss here. So, we will talk about boomerang attack. Boomerang attack on block cipher. Okay, so So, it is a variant of differential attack. So, we are looking for, so in differential attack what we are doing, we have a R round block cipher and we are just looking for if R, and then we are just looking for a difference in this long round like R minus 1 rounds. So, we are looking for a difference alpha is going to beta in this long round. So, that difference may exist, may not exist. So, that is the problem with differential attack, because this is a long round. Okay. So, the idea is if we instead of long round, if we have a short round, short difference, like if we have difference up to this, then if we have difference up to this, then can you mount a attack. So, that is the version of differential attack, that is called boomerang attack. So, in boomerang attack what we have, say we have a plain text, we have this block cipher which is basically n bit and suppose we break this into E0, I mean E1 E0. So, that means we have E0, then we have a E1 over here. Okay. Now, suppose we know that there is some difference alpha is going to beta here with probability p. So, we know this, suppose the difference exists, suppose the differential alpha is going to beta with probability p, p is high probability, exists in E0 and suppose here also beta is going to some delta. So, beta is going to delta with probability q in E1. So, suppose these two difference we have, like alpha is going to beta and beta is going to delta. Instead of having long difference, if we can find out some short difference on shorter round, this is the shorter round than whole round. So, like this, then we can mount the, and if this two probability are significantly high, like more than half, then we can think of, then one can mount the differential boomerang attack. So, how? So, basically what we will do here, so idea of this attack is, so we know the differential here is alpha beta and here differential is beta delta. Okay. Now, what we do, we first choose a plain text over here. So, this is our block cipher, we first choose a plain text P1 P2 such that P1 XOR P2 is alpha. Okay. And this is a chosen plain text attack, not only chosen plain text attack, it is also chosen ciphertext attack. So, this boomerang attack is it is chosen plain text as well as chosen ciphertext. Why chosen ciphertext will come in a moment. Okay, so now the input difference is alpha. Now we encrypt. So, this is the block cipher. So, this is chosen plain text attack. So, it will give us C1 C2. So, C1 C2 is the ciphertext corresponding to P1 P2. Okay. Now, what we do? We choose C3 C4 such that C3 is basically C1 XOR delta and C4 is basically C2 XOR delta. Now, so that C1 C3 if we take their input their difference is delta. Okay. Now, if their difference is delta, now here, so if we have alpha over here, we will get beta over here, we will get delta over here with high probability. So, that is the difference we have. So, if alpha is the difference over here and if the delta is the difference over here, then we should have difference over here beta. Okay. So, yeah, so how we can mount this attack? So, now we choose a C1 C3 C4 like this. So, their input difference is, so now this is a chosen ciphertext only attack also. So, now we get corresponding plain text, we will give the input as this ciphertext. So, we will get P3 P4. Okay. Now this is now P3 P4 we get. So, now we know this fact that C1 so we know this fact C3. So, if we come back here C3 export XOR with E1 inverse C4. So, this should give us beta, which is again same as E0 P3 XOR E0 P4. So, that means we check this, if E0, if this is, so we check this, if this is alpha, then we increase the counter by 1. So, we are expecting this to be alpha, because we are choosing this delta. So, that means we should get here beta. So, that means if we get here beta, then their difference should be alpha. So, if we get alpha, then we will increase the counter by 1 like this. So, this is basically the attack model of this boomerang attack, but here we do not require the long differential, we can have short differential, then also we can just mount the differential attack by this way. So, let us just write the attack in formal way. So, step by step. Okay, so boomerang attack. So, we just step 1. So, we know the alpha beta difference is there. So, we ask for, we choose a plain text P1 P2 such that P1 XOR P2 is alpha. Okay, and we get the corresponding ciphertext. From here we get the corresponding ciphertext C1 and C2. Okay. So, this is the step 1. So, step 2 is basically we choose C3, which is basically C1 XOR delta, and C4 is basically C2 XOR delta. So, that means C1 C3 have difference delta and C2 C4 is the difference delta, and then we ask. So, this is a chosen ciphertext also. So, we ask to decrypt this plain text to get the decrypt this ciphertext to get P3 P4. Okay. So, once we have P3 P4, then we check, this is the step 3, then we check whether P3 P4 is alpha or not. If it is alpha, then we increase the counter. So, we repeat this step until we get some significant probability, a significant frequency in the this table. Okay. So, this is the boomerang attack. Now, last attack, I will just give you the idea of slide attack, which was introduced by Birukov in 1999 Birikov and Wagner. So, this is slide attack. This is also attack on block cipher. Okay. So, idea is we can slide the block cipher. So, block cipher is R round. So, here in this attack we assume all the round functions are similar, which is f. So, this is R round block cipher. Okay, so this is plain text, this is ciphertext, and we are assuming. So, this is an ideal case. We are assuming all the round functions are same. For AES, for DES, almost they are same because they are all Fistel structure, but in the first round we have a IP of we have a extra permutation operation, and in the AES we have same, but in the last round we do not have the mixed column operation. So, anyway, so this is the block cipher where we are assuming for in order to have this slide attack to work, we need to have all the these are same, and we have the same key. Now, what we do? We slide this one position. So, suppose this is P and this is C, this is plain text, this is ciphertext. Now, we take this as a plain text over here. We slide this structure in one position. So, another f must be there, and if we denote this by P star. So, P star is basically f of P, and then what is the C star? Then the C star will be, because this is C basically. So, C star will be basically f of C. Okay. Now, from these two equations, if we can solve the key, so key are we are assuming same. So, we have a same key for all round, same key. So, comma k, comma k. So, from this, if we can solve k, So, that is the attack. If we have this equation, if we can solve k. So, this is not always it is possible to get the solution. If this f is a easy function, then one can, then we can solve k from this. And one example of easy function is 3 round DES is a easy function. So, this attack they have applied on 3 round DES, this slide attack. So, reduced round DES. Okay. So, thank you.